Hello, good morning students. How are you? All of you fine? Okay. Today we will discuss about your binomial theorem. X plus a whole to the power n. What is n? N is an positive integer, or you can say n is a natural number. So you can write this x plus a to the power n is equal to nc0 x to the power n plus nc1 x to the power n minus 1 into a plus nc2 x to the power n minus 2 into a square plus dot dot plus ncr. If we take any rth term, ncr x to the power n minus r into a to the power r plus dot dot plus last term is what? When r is equal to n, then ncn value is equal to what? 1. So we can write it is ncn and x to the power n minus r, that means x to the power r value n. If n it is x to the power 0, that is equal to 1, so a to the power n. Simply this is what it is called your binomial theorem. And here C0, C1, C2, C3 up to Cn, these are called the binomial coefficients. Write down. Number 1, C0, NC0, NC1, NC2 dot dot NCN. These are called binomial coefficients. Write down. Called binomial coefficients. These are called binomial coefficients. Now second thing is what? Here degree of x plus a is equal to what? Now n. Degree of x plus a is equal to what? N. Now you see, this binomial theorem contains, this theorem contains how many terms? Number of terms. You see, it is started from 1 and ending with n. nc1, nc2, nc3 up to ncn. So how many terms these are? These are n terms, and remaining one term is c0. So total number of terms contain this theorem is n plus 1. So total number of terms, write down total number of terms is equal to n plus 1. That means it contains n plus 1 number of terms. Now third things. What is third things? You see, always you look here. Here x power is n. So in each term it contains the highest power is equal to what? If it is a to the power 1 and this is n minus 1, the sum of this power is equal to what? N. Always you see sum of all the powers of the term is equal to n. Write down sum of all the powers of each terms is n. Sum of all the power of each term is equal to n. This is what? Third things. And fourth things, you see, what about we can say this term ncr x to the power n minus r into a to the power, this term is called your general terms. What is this? Because here is no constant value, here r is variable. Okay, so we can say this is called the general term. You write down the general term is equal to what? General terms. General terms. So which term it is? If I am taking, similarly, if I am taking 1 to r, that is rth term. Yes or no? Then first term is c0. If it is started from 0 to r, then we can say this is what? T r plus 1 term. Write down T r plus 1 is equal to ncr x to the power n minus r into a to the power r. Got it? So this is what? the general term, we can say r plus 1 term is the general term. Here r is equal this term is t r plus 1, we can write ncr t r plus 1 is equal to ncr x to the power n minus r into a to the power r. This is what your general term. Now you see, we can now study the properties of binomial theorem. Now you see, before going to discuss about the properties, this can be expressed in the summation form. How can we write summation form? Number 5, summation form x plus a to the power n is equal to, we can write summation of r varies from 0 to n ncr x to the power n minus r into a to the power r. Now you see, you put here r value is equal to 0. If r is equal to 0, then it is nc0 x to the power n a to the power 0. A to the power 0 means 1. So this will be first term, nc0 x to the power n. Then put r is equal to 1. R varies from 0 to n. R varies from 0 to n. Then second term will be what? If r is equal to 1, nc1 x to the power n minus 1 into a to the power 1. So a to the power 1 is equal to a. This one is the second term. Similarly, r is equal to, put r is equal to 2. R is equal to 2 if it is nc2 x to the power n minus 2 into a to the power 2. So like this you can express this total figure into the summation form, and the summation means it is plus addition of two consecutive terms. That is what summation of, that is what it is, the summation of r varies from 0 to n ncr x to the power n minus r into a to the power r. Now you see, if we put the value of a is equal to 1, then what will be this? This term will be, write down, if a is equal to 1, put here, we can write this, if a is equal to 1, if a is equal to 1, then it will be x plus 1, or you may write 1 plus x, because x plus 1 is equal to 1 plus x. So this will be x plus 1 to the power n, or this can be written 1 plus x to the power n. So what will be this? This will be written by two ways. We can write the power of n may be descending order, or power of x in the descending order, and power of x is also in the ascending order. So if we can write x plus 1 whole to the power n, this will be written nc0 x to the power n plus nc1 x to the power n minus 1 into 1 power 1. What is this? Value is equal to 1. So we can write plus nc2 x to the power n minus 2 plus dot 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 plus ncn. Then 1 to the power n is equal to 1. So this can be, this nc0 term, this nc0 term, combination term, can be written in the form of, this can be written c0 x to the power n plus c1 x to the power n minus 1 plus c2 x to the power n minus 2 plus dot 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 plus cn. So this is c0, c1, c2 up to cn, these are called the binomial coefficients. Similarly, if we can write it in the ascending power of, this is the descending power of n. You see x to the power n, here x to the power n minus 1, so descending power of its power of x. Now you can write 1 plus x whole to the power n. If we can write this, this will be c0 nc0 plus nc1 x plus nc2 x square plus dot dot plus ncn x to the power n. So this value is always remain this term and this term both are same term, but it is ascending power of x and this one is descending power of x. Now here we write another things. Number 1, this is number 2, number 3. If you put a is equal to minus 1, then what happen? If we put a is equal to minus 1, a is equal to minus 1, then it will be x minus 1 whole to the power n. X minus 1 whole to the power n. Then what will be its value? This will be nc0 x to the power n plus nc1 x to the power n minus 1 into minus 1 plus nc2 x to the power n minus 2 into minus 1 square plus like this plus ncn x to the power n minus n, this is equal to 0 to minus 1 to the power n. So this is what x minus 1 whole to the power n. Okay. So if I am writing instead of a, that will be minus a. Instead of a, that will be minus a. Then what happen? Fourth thing, x minus a whole to the power n. That will be nc0 x to the power n plus nc1 x to the power n minus 1 into minus a plus nc2 x to the power n minus 2 into minus a square, that is equal to a square plus dot dot dot. Last term is nc n x to the power n minus n, that will be 0, and this is minus a to the power n. So this one is last term. That will be written nc0 x to the power n minus nc1 x to the power n minus 1 into a plus nc2 x to the power n minus 2 into a square plus dot dot plus ncn minus 1 to the power n into a to the power n. So this is what it is, the x minus a whole to the power n is equal to this. Always n is a positive integer or n you can take it is a natural number. So now we will find out the addition of these two terms. What will be its addition? You see, now you see, if we add these two terms, what will we get? You see, x plus a whole to the power n, and here x minus a whole to the power n. So write down x plus a whole to the power n plus x minus a whole to the power n. Now you add these two terms. This is what? nc0 x to the power n. Here is nc0 x to the power n. So this will be 2 into nc0 x to the power n. Clear? Plus, then you see minus of nc1 x to the power n minus 1 into a, and it is plus of nc1 x to the power n minus 1 into a. So these two terms cancel out. This term and this term cancel out. So what will be this? Next term we will get nc2 x to the power n minus 2 into a square. Here nc2 x to the power n minus 2 into a square. This term will be add. So we can get here only even term. Here is even term. Odd term will be cancelled out because due to the presence of the power minus 1 to the power minus 1 to the power. If it is minus 1 odd power, then it will be cancelled out. So only even term we will get. So write down, this will be nc2 x to the power n minus 2 into a square plus, then what will be the next term? Next term will be nc4 x to the power n minus 4 into a to the power 4 plus dot dot. So this is what the addition of two binomial expressions, this and this term. If we will add, then we will get this. Then if we will subtract, then what will be what is the things, what will be the expression? Then we can write x plus a whole to the power n minus x minus a whole to the power n. So here is, we can cut here only the even terms. You see, this one is the first term, this is the second term, and the fourth term will be cancel out. Now if we will minus this, then first term will be cancel out. This will be positive, this will be negative. You see, this term is negative, this will be positive, changing the sign. This term is negative, this term is positive, like this. So first term will be cancel out. Then what will be this? nc1 x to the power n minus 1 into a, and nc1 x to the power n minus 1 into a. So this will be 2 into, write down nc1, only odd terms, 2 into nc1 x to the power n minus 1 into a. Then next term will be what? nc1, then odd term will be nc3. So nc3 x to the power n minus 3 into aq plus nc5, next term is nc5, nc5 x to the power n minus 5 into a to the power 5 plus dot dot. So like this is what, this is the summation of all the odd terms. This is what, if we will add this term, we will get summation of all the even terms. Got it? So then next we will see the term remaining from the term beginning and term ending. Both are, the coefficient of a term beginning and the coefficient of a term ending, both are equal. That means sixth, NCR, coefficient of this binomial expression, we can write it NCR. It is beginning from the term, and if we taken it from the last, if we will consider from the last, that will be NC n minus r. NCR is equal to NC n minus r. This is also, you know, from the combinations. What is your NCR? This will be, we can write, you can prove this, NCR is equal to n factorial divided by r factorial into n minus r factorial. Similarly, nc n minus r is equal to what? This can be nc n minus r. What will be this? This can be written n factorial divided by n minus r factorial into n minus r factorials. Got it? So what will this? This can be written n factorial divided by n minus r factorial into n minus n, cancel out, that will be r factorial. You see, NCR is equal to n factorial divided by r factorial into n minus r factorial. Okay. Again we get here nc n minus r is equal to n factorial divided by n minus r factorial into r factorial. That's why that is NCR is equal to NC n minus r. All of you getting? Any doubt? Getting this? NCR is equal to NC n minus r. Now you see, we will go simple examples of binomial expression. Some examples. How can we calculate? How can you find out the binomial expression? How can you expand this? Suppose I am taking here x plus examples. Simple, very simple. X plus y 2y to the power 4. Simply you expand this. How can you expand? You see, first term is x. Then we can write first term is x. First term is equal to x. What is second term? Second term is equal to 2y. Second term is equal to 2y. Then we can write it, the power n is equal to 4. Okay, got it? So now you see x plus 2y, x plus 2y power is equal to 4. According to the formula nc0, here it is 4c0, and x to the power n, then you can write x to the power 4, x to the power 4 plus, what is this, second term is equal to 2y, then you can write nc1, nc1 means 4c1, and x to the power n minus 1, n is equal to 4, 4 minus 1 is equal to 3 into 2y. Then next term plus nc2 means 4c2 x square 2y square, then 4c3 x cube, this is x 2y cube, and last term is nc4, 4c4 2y to the power 4. Got it? So this is the expansion of x plus 2y to the power 4. This is the expansion term. Then you can simplify this. 4c0 value, 4c0 is equal to 4 factorial. Similarly, write down 4 factorial divided by 0 factorial into 4 minus 0 factorial. 4 factorial cancel out, and 0 factorial value is equal to 1. So we can write it is x to the power 4. 4c1 value, similarly 4 x cube into 2y. Then 4c2 value 4 factorial divided by 2 factorial into 4 minus 2 is equal to 2 factorial. So 2 factorial value 2, here 2 factorial 2 into 2 equal to 4, 4 cancel out, so 3 into 2, that is equal to 6 x square into 2 square means 4 y square. Similarly 4c3 value is equal to 4, so we can write 4x 2 to the power 3 means 8y cube plus 4 value is equal to 1. So this is equal to 2 to the power 4 into y to the power 4. What will be this? This is equal to x to the power 4, 8 plus 8x cube y, okay, plus 24x square y square plus 8 into 4, 32. 8 into 4 what? 32 y cube xy cube plus 2 to the power 4 equal to 16 y to the power 4. Getting this? All of you got it? Any doubt? You see, this is the expansion of a binomial theorem. Similarly, you can take here another example. If we can write it 1 plus, write down another example, example 2. Suppose x plus 1 by x to the power 5. X plus 1 by x to the power 5. Then what will be this? This will be by expansion, the first term is equal to x, second term is equal to 1 by x, and the power is equal to n value is equal to 5. So we can write, and in which way? This is 5c0 value 1. So 5c0 x to the power 5 plus 5c1 x to the power 5 minus 1 4 into 1 by x plus 5c2 x to the power 3 into 1 by x square plus 5c3 x square into 1 by x cube plus 5c4 x into 1 by x to the power 4 plus 5c5 x, and this is this value 1 by x to the power 5. Okay, So what will be after simplification? You can write 5c0 x to the power 5 plus 5c1 x to the power 3 plus 5c2 x plus 5c2 x square x, then 5c3 into 1 by x cube 1 by x cube 5c3 1 by x, sorry, 5c3 it is 1 by x plus 5c4 1 by x to the power 4 plus 5c5 1 by x to the power 5. Got it? So like this you can find out how many terms: 1, 2, 3, 4, 5, 6 terms. So we can get here the 6 terms. N is equal to 5, then 5 plus 1, that it will be 6. Okay. So by this way we can find out, we can know about the binomial theorem and its expansion.